This is a video for AQA Further Pure Mathematics. This is Vectors section 2.3 where we're looking at the equation of a line, three dimensionals in Cartesian form. Well, the vector equation that we've looked at in two dimensions, r is equal to xy is equal to a1, a2 plus lambda d1, d2. In other words, a point on the line and a direction. If you think about that, we can rearrange the equation. For x, you can see that we get that x is equal to a1 lambda d1 and y is equal to a2 lambda d2. So therefore we could equate those two things, both being equal to lambda, and we get x1 minus a1 over d1 is equal to y minus a2 over d2. And that gives us what's called the Cartesian equation of the line. In three dimensions, exactly the same thing can be done, and this time we get x minus a1 over d1 equals y minus a1 over d2 equal to z minus a3 over d3. The equation is normally given without the lambda equals, that's an implied thing. So quite often vector equations are not always, or Cartesian equations are not always the easiest thing to work with, so we might want to convert from one to the other. Usually we're going to be converting from Cartesian form into vector form. But we'll start off by looking at a straightforward example in two dimensions, which is going from a vector equation to a Cartesian. So you can see here then that we've got the vector equation r is equal to 1, negative 3 plus lambda 2, 5. So from that then we can say that x must be equal to 1 plus 2 lambda, just equating the left hand side with the right hand side, and y is equal to minus 3 plus 5 lambda. The top one gives us lambda is equal to x minus 1 over 2, and the second one gives lambda is equal to y plus 3 divided by 5. Well, those two expressions both being equal to lambda means that our Cartesian equation is then x minus 1 over 2 is equal to y plus 3 over 5. And if we rearrange that by multiplying by 10, so that gives us 5x minus 5 on the left hand side and 2y plus 6 on the right hand side. Well, writing it in the form we've been asked to give, that's 5x minus 2y is equal to 11. Now that completes the question as set, but just to point out that if we were to look at that and write the equation for y, we could see that 2y is equal to 5x minus 11, and therefore y is equal to 5 over 2x minus 11 over 2. And the 5 over 2, sorry, should that be 5 over 2 there? 5 over 2 is the gradient of the line that we'd get by using the idea that the gradient of our line M is equal to the d2 rather, divided by d1, so the y value divided by the x value, and that would be equal to 5 over 2. And there's the same thing just written out neatly so that you can work through it yourselves. Well, in summary of that then, the next slide just looks at it algebraically, shows how we did that. We wrote lambda first of all in terms of x and then y and equated, and then rearranging. And we can see then that the gradient of the line is d2 over d1. Now there's no need for you to be able to do it algebraically, that's just there in summary of the method. Well, if we move to 3 dimensions, the method is entirely equivalent to that. So there's our vector equation, 3 dimensions, and then we can write equations for x, y and z, and from those get lambda and equate that. So x minus a1 over d1 equals y minus a2 over d2 equals z minus a2 over d3, each of those being equal to lambda. And of course it's possible to shortcut that and go straight to our solution. So in this one here we can see that we've got x minus a1, that's x minus 2 over d1 is 1, is equal to y minus a2, that's 0, so y divided by 4 is equal to z minus a3, so that's z minus negative 3 or z plus 3 divided by negative 2 is our Cartesian form. All of those coming from the fact that they are expressions for lambda. Well, given a Cartesian equation, we can work backwards, use the same sort of idea. So here we can see in the first part of the expression we've got x minus a1 over d1, or putting it another way, we can say that x is equal to 1 plus 2 lambda, y is equal to negative 2 minus 4 lambda, and finally z is equal to 3 lambda. And therefore our expression r, which is x, y, z, is the point A, which is 1, negative 2 and 0, simply reading across from the values of a1, a2 and a3, and then lambda times the direction vector 2, negative 4 and 3. And again that written out neatly for you. Well, just as a parting shot, as it were, there's something for you to think about is how you would find the equation of a line through 2 points in Cartesian form in 3 dimensions. It's not one that I'm going to do, but perhaps you might want to try it. One method would be to convert, first of all, this to its vector equation, or write down the vector equation rather, and then convert from that into Cartesian form by the methods we've just been looking at. So the vector equation, of course, is quite straightforward. We'd need to work out, if this was A and B, we'd need to work out the vector from A to B and write it in the form R is equal to position vector of A plus lambda times AB. Once we've done that, we can then read off our Cartesian equation in the same sort of way as we've been doing in the previous slides. I'll leave that one with you to try yourselves. So that's the end of this particular video, and in the next one we'll be looking at the intersection of 2 lines in 2 dimensions.